Okay, so today we're going to use calculus to determine the present and future value of money. This is a really key concept in business and finance. Money has a value right now, and it has a future value. Because if you have money in hand, you can invest it and it'll grow. So money in hand right now is worth more than money that somebody would give you later. It's always better to have money now because then it can grow. Okay, so Big Tree McGee is negotiating his rookie contract with a professional basketball team, and they have agreed to a 3-year deal, which will pay Big Tree a fixed amount at the end of each of the 3 years, plus a signing bonus at the beginning of his first year. They're still haggling about the amounts, and Big Tree must decide between a big signing bonus and fixed payments per year, or a smaller bonus with payments increasing each year, and the two options are summarized in this table, and all the payments are in millions of dollars. So he has to decide between these two options. So let's just calculate how much money total each of these options is. So we have 6, 8, 10, 12 million. This is 12 million total. And this is 3, 7, this is 13 million. So option 1, they pay him $12 million, and option 2, they pay him $13 million. So you might instinctually choose option 2, right? It's more money. However, option 1 gives him $6 million on day 0, right? His signing bonus is $6 million, half of the money up front, which means that he can invest that $6 million and let it grow. So that investment might make up for, or more than make up for, the extra million that they're willing to pay him in option 2. So we have to decide, we have to do some calculations to determine the future value of both of these options, the present and the future value. So he's going to invest all his income in stock funds, which he expects to grow at a rate of 10% per year, compounded continuously. He wants to choose the contract option, which gives him the greater future value at the end of the 3 years when the last payment is made. So we're going to calculate the future value of option number 2. So we'll just do option 2. Option 1 you'll find later in your activities. So option 2, future value. Okay, so he's going to get $1 million on day 1, right? $1 million, and then he's going to invest that $1 million compounded continuously at 10% per year for 3 years. So we have 1 million times e to the 0.1 times 3. You guys remember this formula, PE to the RT, from a previous course? So it was future value is present value e to the RT. That's the formula for continuously compounding money. So $1 million, 10%, 3 years. All right, and then he's going to get $2 million for his next payment, and that's going to get invested for 2 years because it happens at the end of the first year, so he's got 2 years left. So e to the 0.1 times 2, then he gets $4 million, e to the 0.1. He only gets 1 year to invest that, and then $6 million is the very last payment at the end of the 3rd year, so it doesn't get invested. So we add this all up, and we get approximately $14.21 million. So that's the future value of option 2. So option 2 is a total of 13 million, but it's actually worth 14.21 million because he can invest the money as he gets it. All right, so I want to calculate the present value of option 2 using our final answer to part A. So if we know that the future value of the money is $14.2 million, how much would they have to pay him today so that he could have $14.2 million 3 years from now? So we're going to use the same formula. Future value is present value times e to the 0.1 t, assuming the 10% interest rate again. So my future value I know is 14.21. Present value is what I'm looking for, so P for present. e to the 0.1 for 3 years. And we want to solve for the p. So p is going to be 14.21 million divided by e to the 0.3. Anybody have it? I'll pull up my calculator. 14.21 divided by e to the 0.3. So we get 10.53. So option 2 is equivalent to saying we'll pay you $10.53 million today. Or you could wait 3 years and we'll pay you $14.21 million 3 years from now. Or we can pay you $1 million now, $2 million next year, $4 million the year after that, and $6 million the year after that. Those are all equivalent future valued means of paying him. Okay, so here are the formulas from a pre-calculus course. If P is the present value of an investment, F is the future value of an investment, T is time, and R is the APR, the interest rate. So for continuous compounding, F is PE to the RT. This is what we've been using. Future value is present value times E to the RT. And then you just solve this equation for P to get an equation for present value. So present value is F over E to the RT or F times E to the negative RT, because you just take that from the denominator and move it up, make the exponent negative. And then annual compounding, which is less common, was F equals P times 1 plus R to the T, and then solve for the P to get the present value formula. So if we view payments as being discrete, meaning occurring at distinct intervals like 1 time per year, computing future and present value involves no calculus. You'll notice we haven't done any calculus yet. However, for some companies, it makes sense to view income or expenses as continuous, and we call this an income stream. And we might say a company is earning P of T dollars per year. P of T is the income stream. So for example, suppose we open a calculus tutoring business and we estimate that T years after opening our doors, we'll have an income stream of P of T, which is 400 times T plus 1 squared dollars per year. So let's calculate our income stream 1 year after we open the doors. P of 1, we think that we'll be making 400 times 1 plus 1 squared, or $1,600 per year. P of 2, 400 times 2 plus 1 squared, or $3,600 per year. And then P of 10, 10 years after we open this business, we have 400 times 10 plus 1 squared, which is $48,400 per year. So I want to find the present and future value of our business. So businesses get valued all the time. You read it in the news, right? They'll say, you know, Amazon is worth $1 gajillion, right? This is what they mean by how much a business is worth. They calculate, they look at its income stream, and they project a future value and a present value based on how much income comes in, plus some other concepts. Okay, so we want to find the present and future value of our business over 10 years. Given an income stream of P of T is 400 times T plus 1 squared dollars per year, that we are going to instantly invest at an interest rate of 4% compounded continuously. So our income stream changes over time. So it's not a constant amount. So I can't do the thing I did with Big Tree, right? I can't just take the 6 million and invest it, because the income is always changing. So the idea is to cut up the 10 years into a bunch of little time intervals where the income streaming in on each tiny interval is basically constant. So here I have a timeline, 0 to 10 years, and I picked a random moment in time t that we're going to investigate its future and its present value. So this random moment in time t means that this distance from 0 to t, this time distance, is just t years, right? And then the distance from t to 10, what's that? How many years is that? 10 minus t. Years. So the length of this interval from t to t plus delta t, the length of that interval is delta t years. Okay, so I want to think about how much money in dollars comes in on that little interval, that tiny small interval. How much money in dollars? We'll have a formula for how many dollars per year are coming in, right? So I'll just plug in my formula, 400 times t plus 1 squared. This is dollars per year, right? But I just want an amount of money. How many dollars am I making in that small time interval? Okay, so I need to multiply by the length of time that I'm earning this money. What is the length of time? Delta t. So I'm going to multiply times delta t years so that my years cancel and I just have dollars. Right, so the income that comes in on that teeny tiny interval is the income stream times delta t. And then the future value of that income, I'm going to project it into the future, investing it in an account that makes 4% interest compounded continuously for the remainder of the time that it's invested, right? So for 10 minus t years, we're going to invest that amount of money. So the future value is the present value, 400 times t plus 1 squared delta t. That's the current amount of money. And I'm going to project it forward. So I do times e to the r, which is 0.04. And then how long are we projecting it forward? 10 minus t years. So that is the future value of my income. Let's see if we can come up with the present value of that amount of money. So the present value formula, just jump back real quick. The present value formula is this one. So now we're going backwards in time. So we have a sort of a subtle shift of how we're viewing the amount of money that comes in on this small time interval. So we were thinking of it as a present value and we're projecting it forward. Now we're going to think of it as a future value, and I want to go backwards in time. So think of it as a future value, and I'm trying to go back to what was it worth at time 0. So take the amount of money, 400 times t plus 1 squared delta t. That's just the amount of money. And now I want to go backwards in time from t back to 0. So it's going to be e to the negative 0.04. And how many years backwards am I going? T years. So that's the present value of that amount of money that we make on that teeny tiny delta t interval. So finally, now I know the future value and the present value of this tiny slice of time, the money that comes in on this tiny slice of time. Now I just have to add all these up. And when you take a limit, as the number of slices goes to infinity, you get, of course, an integral. All right, so if I want to know the present value, so this is my present value formula for a single slice of time. So I need to add up all my slices. 400 times, throw some i's on here because this is a Riemann sum. And I'm going to let I go from 1 to n and take a limit as n goes to infinity. and then that gets converted to a definite integral. So this is the integral of 400 times t plus 1 squared e to the negative 0.04 t dt. And then my bounds of integration, let's go back and look at the picture. The bounds of integration are 0 to 10. That's where I'm stacking up these slices of time and figuring out how much money comes in on each slice. So from time 0 to time 10. And then we're just going to have a calculator evaluate this integral for us. So 0 to 10 of x plus 1 squared, oops, squared, times e to the negative 0.04 t, or x, because I'm using x, dx. So 332.88. That is the present value of my business. The day I open the doors of this business, it's worth $332.88. So if I just invest $332.88 for 10 years, that would be equivalent to running this business for 10 years. All right, let's calculate the future value using my formula for future value here on my single slice. So it's going to be a sum where I add up all these slices. Okay, t plus 1 squared, e to the future value formula is 0.04 times 10 minus t delta t. And I should technically have some i's on my t's. And this goes from 1 to n, and I take the limit as n goes to infinity and convert that to a definite integral. And the bounds of integration are again 0 to 10. That's where I'm adding all these slices up, time 0 to time 10. And we'll calculate the future value of our business 10 years after we open the doors. So that's the same. And then this is going to be e to the positive 0.04 times 10 minus x. $496.60. All right, that's it for the demo. Work on the activities. Okay, I realized that I left out the 400 on both of these integrals. So multiply both of these numbers times 400, because you can just pull that right out of the integral anyway. So times 400 is much bigger, 198,639.31. That's the second one. So the value of your business after 10 years is 198,639.31. Yeah. Okay, so then let's pull up my previous integral. There we go. So that 332 actually needs to get multiplied by 400. And so 133,151. 133,151. Yeah. All right, that makes a lot more sense.